Let's go over the Fibonacci sequence. The Fibonacci sequence is a very popular concept when teaching or learning recursion. This is because the Fibonacci numbers are often defined recursively. What is the Fibonacci sequence? The Fibonacci sequence is a series of numbers where the next number is found by adding the two numbers before it. Let's take a look at this table. If you look at the second row on this table, if 0 is entered in as an argument, then the Fibonacci will give us 0. If 1 is entered, then the Fibonacci sequence will give us 1. So the next number is found by adding the two numbers before it. So if 2 is entered as an argument, then you would add the two numbers before it. So 0 plus 1 is 1. If 3 is entered, you would add the two numbers before it. 1 plus 1, 2. Now for Fibonacci 4, add the two numbers before it. 1 plus 2 is 3. For Fibonacci 5, you add the two numbers before it. 2 plus 3 is 5. For Fibonacci 6, you would add 3 plus 5 is 8. And so on and so forth. Now what's obvious here is this right here, this is our base case. Now before we examine the code, let me give you a little history on Fibonacci demand. This picture right here is a picture of Fibonacci. But he was not the first to know about the sequence. It was known in India hundreds of years before. His real name is Leonardo Pisano Baglio. I don't know if I'm pronouncing that correctly, but he lived between 1170 and 1250 in Italy. Fibonacci was his nickname, which means son of Bonacci. Now, Fibonacci Day is known for November 23rd because it has the digits 1123, which is part of the sequence. So don't forget to wear your Fibonacci t-shirts on November 23rd. On that note, let's start coding. Our function's name will just be Fibonacci. And the first thing we want to do is target the base case. Now, if you look at the right, if n is 0 or 1, then the return case will be 0 and 1. So we can say if data equals 0, then we return 0. Else if data equals 1, then we want to return 1. Let's test this real quick. So here I'm just going to assign Fibonacci to an integer variable called fib. And that's because the data type for Fibonacci is an int. So when the function returns that integer value, whether it's 0 or 1, we're storing it into fib. So let's run this. And there it is. We get 0. And let's do 1. There it is. Actually, we can refactor this because we know that if it's 0 or 1, then we're just going to return the same number. So we can say if data equals 0 or the two vertical lines, data is 1, why don't we just return data? So that way we don't need this. So let's see if this works as well. Let me run this with a argument of 1. Okay, let me run this with an argument of 0. All right, so that works. So now let's write our recursive case. So before we write the recursive case, let's discuss the logic. So say we're at 6. In order to get Fibonacci 6, we would have to add these two numbers together. So this would be n. So the question is, how do we add the two numbers before it? If this is n, then this is n minus 1. And if this is n minus 1, then this is n minus 2. So if we add n minus 2 plus n minus 1, then we should get n. So it ought to equal n. All right, so let's code that. For our code, it's really simple. All we're really doing is returning, and here we're going to make our recursive call Fibonacci n minus 2 plus Fibonacci n minus 1. And that's it. So let's test this. Put in Fibonacci 6. Sorry, this should be data minus 2 and data minus 1. All right, so let's try it again. So there it is. Fibonacci of 6 gives us 8. Do Fibonacci of 5. Fibonacci of 5 gives us 5. Fibonacci of 4 should give us 3. And then Fibonacci of 3, that should give us 2. And Fibonacci of 2 ought to give us 1. So here's the question. What happens if I remove this data equals 1 from our base case? So let me do that and compile this. Let me make this a 6. And notice what happens. It doesn't return 0. Let me make this a 5. So what happens is that this function never terminates and it goes into a stack overflow. Remember, the main point of having a base condition is so that the condition becoming false can terminate the loop. And that's why it's important that we have our base case to terminate. Otherwise, it goes into an infinite loop where we get an error because of a stack overflow. And that's pretty much the code for the Fibonacci sequence. On our next video, we are going to use the stack frame to trace the Fibonacci function. Thank you for watching.